Bismillahirrahmanirrahim. Assalamu alaikum students. My name is Afia Farooq, Divisional Public School and Intermediate College, Lahore. Welcome students. We have started chapter number 9 and the topic is chords of a circle. First, we will revise what we have learned in our previous lecture. Circle. A circle is the locus of a moving point in a plane which is always equidistant from a fixed point. Radius. Radial segment of a circle is a line segment determined by the center and a point on the circle. Circumference is the boundary of the circle traced by a moving point P. Arc. Any curved portion of a circumference of a circle is called arc. Chord is a line segment joining any 2 points on the circumference of a circle. Diameter is a special chord and is the longest chord that passes through the center of a circle. Segment. A portion of a circle bounded by an arc and corresponding chord. Sector. A sector is the portion of a circle bounded by 2 radii and the arc intercepted between them. Central angle. Angle of a circle whose vertex is at the center O and its arms meet at the endpoints of the arc. Now we will discuss theorem number 2, and the statement is given below as: a straight line drawn from the center of a circle to bisect a chord which is not a diameter is perpendicular to the chord. Bisect means to divide chord into 2 equal lengths or parts. Perpendicular means that if we say two lines are perpendicular, then these two lines make an angle of 90 degree with each other. Students, from the given statement, first we have to know that what is given and what we have to prove. Here, look into this figure. O is the center of a circle, and from the statement we know that there is a chord AB that is not diameter. As we know that diameter is also a chord that passes through the center of the circle. So we have to consider a chord that is not diameter. Then the next given statement or information is that if we draw a line segment or straight line OM from the center of the circle to the chord AB, then this line segment OM will cut the chord AB into 2 equal parts, as first part is AM and the second part is BM. So from this information we come to know that M is the midpoint of the chord AB, because the line segment, if M is the midpoint, then the line segment OM will cut the chord AB into 2 equal parts. Now we have to prove that OM is perpendicular to the chord AB. So if we prove that the line segment OM makes an angle of 90 degree with the chord AB, then we will automatically prove that OM is perpendicular to the chord AB. So we will label these two angles as angle 1 and angle 2, and we will prove angle 1 is of 90 degree and angle 2 is also of 90 degree. Given, as we know that M is the midpoint of any chord AB of a circle with center at O, where chord AB is not the diameter of the circle, and we have to prove OM, the line segment OM, is perpendicular to the chord AB. This is the symbol or sign of perpendicular. Construction. Join A and B with center O. First we will join A with O and then B with O, and then write angle 1 and angle 2 as shown in the figure. Now we will prove these statements with the help of reasons. As students, in triangle OAM, that is corresponding to triangle OBM, we have to find, is there any resemblance or similarity between these two triangles. One is OAM, that is colored with yellow, and other is OBM, that is colored with green. So measurement of line segment OA is equal to measurement of line segment OB. How can we say that measurement of line segment OA is equal to the measurement of line segment OB? As we know that, students, OA is the side of the triangle OAM and OB is the side of the other triangle OBM. And also we know that OA is the radius of the circle. Similarly, OB is also the radius of the circle. This is radius, this is also radius. And as we know that radii of the same circle are of equal length. So that is why we say that measurement OA is equal to measurement of line segment OB as radii of the same circle. Now we have proved that this side of triangle OAM is congruent or similar or equal to this side of triangle OBM. Now measurement of line segment AM is equal to measurement of line segment BM. As students, in given statement, we know that M is the midpoint of the chord AB. So it means that the distance from A to M or the distance from B to M are same. So that is why measurement AM is equal to measurement BM. And also we know that AM is the side of the triangle OAM and BM is the side of the triangle OBM. And we have proved that these two sides are also given equal. Now measurement OM is equal to measurement OM. Students, look into this figure. OM is the common side of both triangles. OM is also the side of triangle OAM and OM is also the side of the triangle OBM. So this is a common side, so that is why this is equal. Here students, we have proved that all three sides of these two triangles are equal. So we can say that triangle OAM is congruent to triangle OBM. This is the symbol or sign of congruent. Congruent means these two triangles are same with respect to size and shape. And we proved this, and we can say triangle OAM is congruent to triangle OBM by SSS postulate. This is also called side-side postulate, as we have proved that all three sides of this triangle are congruent to all the sides of this triangle. Now measurement angle 1 is equal to measurement angle 2 and labeled is as angle equation 1. Students, as we know that these two triangles OAM and OBM are congruent, as we have proved that all three sides of these two triangles are congruent. So if two triangles become congruent and their all three sides are congruent and their all three angles are also congruent. So this angle is congruent to this angle and angle A is congruent to angle B and angle 1 is congruent to angle 2. And reason is corresponding angles of congruent triangles, because measurement angle 1 is equal to measurement angle 2 because these are the corresponding angles of congruent triangles. Now we can write it as measurement angle 1 plus measurement angle 2 is equal to measurement angle AMB. That is the AMB is the angle on the straight line is equal to 180 degree. And reason is that adjacent supplementary angles. Students, what are the adjacent supplementary angles? Adjacent supplementary angles are two angles that share a common side, lie on a straight line, and their sides that are not common lie on a straight line. And as we know that the sum of the angles on straight line is 180 degree. Here students, angle 1 and angle 2 are adjacent supplementary angles because this side or arm OM is common to both angles, and we know that the sum of angles on a straight line is 180 degree. So that is why we say that measurement angle 1 plus measurement angle 2 is equal to 180 degree. And from equation 1 we know that measurement angle 1 is equal to measurement angle 2. So we can write it as from this equation measurement angle 2 can be written as measurement angle 1. So measurement angle 1 plus measurement angle 1 is equal to 2 measurement angle 1 is equal to 180 degree. Here this 2 will be shifted to the right hand side and it will be divided with 180 degree. So we will get measurement angle 1 is equal to 90 degree. This implies that measurement angle 1 is equal to measurement angle 2 is equal to 90 degree from equation 1 and 2. As we know that measurement angle 1 is equal to measurement angle 2, and here we prove that measurement angle 1 is equal to 90 degree. So it means that measurement angle 2 is also of 90 degree. So we have proved that OM is perpendicular to AB, as we have proved that angle 1 or angle 2 both are equal to 90 degree. So it means that OM is perpendicular to AB, as OM make an angle of 90 degree with the chord AB. So it means that OM is perpendicular to the chord AB. Students, we have completed the proof. Please learn this theorem by heart. Thank you. Stay blessed.